Evaluating this complex integral over the circle mod z equal to 3, which means this circle is having the radius 3. When taking the denominator to be equal to 0, what points we are getting? We are getting z equal to 1 and minus 2. Right? Now we need to check which of these points lies inside the circle. So both the points lies inside the circle, right? So we need to apply the Cauchy's integral formula for both these points. Next step is, what is our f of z? Take the f of z to be the numerator, right? Let's move on to the solution now. Now in this integral, this is our integrand. Yes, let me ignore this numerator first. Let's make the partial fractions for this. Just write here z minus 1 and here z plus 2, right? When taking this denominator equal to 0, hide z minus 1 from this denominator and we get z equal to 1 and put this value over here. What you get? We get 1 divided by 3. So writing here 1 divided by 3. Similarly, when taking this denominator to be equal to 0, we need to hide z plus 2 from this denominator, right? And we get here the point z equal to negative 2. Put this point over this fraction, we get 1 divided by minus 3. So writing here minus 1 divided by 3. So this is how we make the partial fractions. Let me take this 1 by 3 outside common and we are getting here 1 divided by z minus 1 divided by 1 divided by z plus 2. Let me use this partial fraction in this integrand. So the required integral becomes now, so this is equal to the integral of, okay, this numerator is our fz. So I'm writing here fz. We have taken 1 by 3 already common. So this is integration of fz divided by z minus 1 dz minus the integration of f of z divided by z plus 2 dz. Now since this fz is our polynomial, so it is analytic inside and on the circle mod z equal to 3. And also the points z equal to 1 and negative 2 lies inside this circle. So therefore we apply the Cauchy's integral formula for both these points. So let's write this. Let me mark this as 1. Since fz is analytic inside and on the circle mod z equal to 3 and z equal to 1 and negative 2 lies inside the given circle. What is f of z? We have f of z to be equal to z cube plus 3z minus 1, the numerator. Because both these points lies inside the circle, the given circle, that is mod z equal to 3. So we apply the Cauchy's integral formula for both these points. For that, we also need the value of f of 1 and also f of negative 2. We need these two values, right? What is f of 1? Just put z equal to 1 over here. We get 1 cube, that is 1 plus 3 minus 1, that is equal to 3. We have here minus 8 minus 6 minus 1, that is equal to minus 15, right? And now we are going to apply the Cauchy's integral formula. What is that formula? That integral of fz divided by z minus z naught over the given circle, whatever may be the radius, that is equal to 2 pi iota f of this z naught. This is the Cauchy's integral formula, right? Okay, so now we apply this formula to evaluate this integral, right? Okay, and from 1 this is equal to 1 divided by 3. We have taken 1 by 3 outside. It is the integral of f of z divided by, first we have taken z minus 1 dz from 1, right? And then minus the integral f of z divided by z plus 2 dz. So when applying the Cauchy's integral formula, we have this value to be equal to 2 pi iota f of 1. Take the format z minus z0. Here we should have f of z0. Here z0 is 1 minus 2 pi iota f of negative 2. z0 here is negative 2. So this is further equal to 1 divided by 3. I am taking 2 pi iota outside. Okay, we have got the value of f1 to be 3 minus the value of f of minus 2 to be minus 15. So that is 3 plus 15. So this is 1 divided by 3, 2 pi iota. 15 plus 3 is 18. So this is 3 and this is 6. So this is equal to 12 pi iota to be the required answer for the given integral. Okay, thank you.